How do we program, transform and sense complex new origami structures? In the summer of 2025, Ars Electronica Futurelab welcomed 2 students from a renowned Tachi Lab at the University of Tokyo to Linz for a 2-month residency. As Key Researcher for Origami Robotics, I work closely with Kanata Warisaya and Hiroki Minami in a mutual exchange of knowledge, transforming their origami geometry concepts into functional origami robots, at the same time learning from their geometric research. Our work follows a design philosophy we call robotic minimalism. We observe geometry in 3-dimensional space, and we will look for and identify the simplest possible connections that we can program motion and add sensors until at last an origami robotic artwork emerges. The resident resulted in 3 unique artworks presented at the Ars Electronica Festival in 2025 in Linz.
This work I named Pirouette. Pirouette is a typical dancing turning in ballet. So when you see it, the ball is somehow spinning. And actually, I'm doing here is I pull from the bottom with motor and just release it. I don't have any motors to spin it, but actually this spins by itself. When I was making this spherical mechanism, I realized this kind of motion. So I'm just pushing from the top, but it spins automatically, so he wants to spin like this. And actually this is happening from the elasticity of the hinge part. So this bouncy motion. So when I press it, some energy are stored in this mechanism, and when I release it, it goes spinning. One thing most interesting to me is hinge tessellation. So it's directly combining the tiling and its motion. This is my 2D trainer example, and you see the tiles are connected at corners and making this synchronized motion overall and expanding and contracting like this. And yeah, I've been exploring this geometry for many years, and I also generalize it into curved surface. So this one, I integrated LEDs and actually sensors here, and so when I compress it, the color change, you see. So the sensor is measuring how it is expanded, and so your hand make interaction with this model and changing the color.
My interest is structures and mechanisms and the beautifulness and its mathematical theories behind it. And I have been working on some mechanisms called origami. So what I'm working on is these structures. So usually origami is thought about one paper with some creases. So it can be deformed between the developed states and flat states. But my work doesn't change this like this. This mechanism is non-developable, and instead of developing, this structure moves like this, like wave motions. Using this motion, like these structures, this shape represents some new possibilities of the origamis. You can feel some possibilities of this Japanese tradition origami. I hope this mechanism is applied in some fields like robotics or some fields that is beneficial for the human societies.
one of my most convenient methods for making these kind of things is using rhombic shape. So maybe you don't see any rhombus here, but actually you can decompose. So these are the fundamental, most small pieces, and you can connect this still moves. This. So main point is the boundary is rhombus, but there's hole making rectangle, and the rectangles contract like this into the line and make this motion. And this works in any arrangement of rhombic tiling. So you can make your own rhombic tiling, and if you give me that one, I can make it kinematic.